Writing chemical formula using valences. Objective: to learn how to write the chemical formulas of compounds using valences. A chemical formula is the symbolic expression of a compound. Formulas denote the actual number of atoms present within a compound. The chemical formula may be used in chemical equations as a representation of chemical reactions. The valence of an atom is the number indicating the electrons in an atom that take part in chemical bonding. The rules of valence. Atoms of group 1A have valences of +1. These elements are lithium, sodium, potassium, rubidium, cesium, and francium. Atoms of groups 2A have valences of +2. These elements include beryllium, magnesium, calcium, strontium, barium, and radium. Oxygen has a valence of -2. Fluorine has a valence of -1. Hydrogen has only one electron, so it can have a valence of +1 or -1. Radicals are groups of atoms that frequently appear in compounds. They have a valence associated with the particular radical. Let's walk through the procedure for writing chemical formulas using sodium fluoride as an example. First, determine the valence of each chemical in the compound. Sodium is a member of group 1A, therefore the valence is +1. Fluorine has a valence of -1. The next step is to write the cation, the positively charged atom, on the left, and the anion, the negatively charged atom, on the right. The formula is written by crisscrossing the valences and making them subscripts. More precisely, the chemical formula for sodium fluoride is written as NaF because ones are not written as part of the formula. Consider a second example, calcium phosphate. In this compound, the calcium ion is a basic radical and the phosphate ion is an acidic radical. The calcium ion has a valence of 2. The phosphate ion has a valence of 3. Write the cation on the left and the anion on the right. Crisscross the valences. Polyatomic radicals must be enclosed in parentheses. The phosphate ion is a polyatomic radical, meaning it must be enclosed in a parenthesis with the subscript written outside. The final formula of calcium phosphate is written as Ca3PO4 2. Summary. Writing the chemical formula of compounds on the basis of the valences involves identifying the anions and cations. The valences of the respective chemicals are written as subscripts and they are exchanged with one another. The atoms of the polyatomic radicals are enclosed in parentheses.